Hi class. Today we will be working on review of index laws. First, let's take a look at our learning intentions. To know the powers are used as a shorthand way of writing repeated multiplications. Okay, for example, x to the power of 3 is just a shorter way to write x times x times x. Okay, and it's very essential when you have like a very big multiplication. For example, x to the power of 100. That's just literally x times x times x times x. There's going to be 100x here. Okay, there's no way for you to write all of them out. Therefore, to write in index form is super important. To understand that index laws for multiplication and division apply only to common bases. To know how to combine powers with the same base under multiplication and divisions, basically the rules we're looking at. To know how to apply powers where brackets are involved. Remember brackets first. So you would think of brackets first. Okay. To know that any number except 0 to the power of 0 is equal to 1. To be able to combine a number of index laws to simplify an expression. All right, let's start with our law 1. Okay, law 1, a to the power of m times a to the power of n. And these two's got the same basis, okay, the same base. So for multiplication, we add the indices. All right, retain the base and end indices. In short, retain the base and end indices. Let's take a look at an example. X to the power of 3 times x to the 4. So that's just equal to, remember, retain the base and add indices. 3 plus 4, x to the power of 7. All right, next example. 2ab squared times 7a squared b cubed. All right, here we know in algebra we don't write every single multiplication sign. We don't show every single multiplication sign because that's gonna look very messy. But to help you understand, I can show you the multiplication sign. Okay, so 2 times a times b squared times our second part here, 7 times a squared times b to the power of 3. And remember, for multiplication, you can just switch the any position. Okay, you can switch the order, and that doesn't make a different answer. Okay, so you can switch the order to have the same answer. So you know, the first index law states retain the base and add the indices. So we're gonna group the letters with the same base. Okay, and of course 2 times 7 would be 14, the easiest part to calculate. And we do a times a to the power of 3 to the power of 2, and times b to the power of 2 times b to the power of 3. Okay, we have grouped the parts with the same base. Okay, and then we combine them. Retain a times a squared, retain the base, and we add indices. 1 plus 2. A to the power of 1 is equal to a. Okay, so there's a hidden 1 there. All right. And times b to the power of 2 plus 3. So our answer is 14, and I'm not going to show the multiplication sign. A cubed, b to the power of 5. Okay. Just to write it clear. B to the power of 5. All right. Next law. Law 2. Again, the same base, but if that's a division, we subtract the indices. So retain the base and subtract the indices. Example 2. Simplify and following using the second index law. So m to the power of 5 would just be 5 take away 3. So m to the power of 2. Okay, m squared. All right, next one. 5x squared y to the power of 4 divided by brackets 10x y squared. Okay, so this entire thing, divide by this entire thing. Remember, division can be expressed as fraction. So let's make it as a fraction. 5x squared over y to the power 4 divided by 10xy squared, this entire thing. And then we simplify that. Okay. 5 and 10 could be simplified. Divided by 5 gives you 2 on the bottom. X squared divided by x will give you x on the top. Y to the power 4 divided by y to the 2. Y squared divided by y squared, which give you y squared on the top. And let's write it in a clearer way. That's just going to be 1/2 xy squared. All right. Those questions we'll be looking at are very similar to those ones. So the key idea is just division can be also be represented in the form of a fraction, and we can work it out. So look at this one, x to the power of 6, a to the power of 3. So on the top, it becomes a to the power of 3 because we can cancel this a to the power of 3 on the bottom. 6 minus 3 is equal to 3. And we look at b to the power of 11 and b to the power of 7. Oh, that's just gonna be b to the power of 11 minus 7. Okay, yeah, let's write it in this way. 6 minus 3, so easier to understand. 11 minus 7. And on the bottom is just 1. Okay, but if you're fluent enough, you don't have to show this one. So I'm gonna erase this 1 on the bottom and just leave it like this. All right, so your answer is gonna be a to the power of 3, b to the power of 4. Okay. D, 20 over 35. This could be simplified. Divide by 5 gives you 4 on top, give you 7 on the divide by 5. Yeah, right. Give you 7 on the bottom. X to the power of 5x. So that's just x to the power of 5 minus 1, which is 4. And y to the power of 8, y to the power of 6. So that's just y to the power of 8 minus 6, which is 2. So your final answer is 4 over 7, x to the power of 4, y squared. Okay, law 3, bracket a to the power of m to the power of n. That's equal to a to the power of m times n. So retain the base and then multiply the indices. And your law 4, bracket a times b to the power of n. It's going to give you a to the power of m times b to the power of m. Distribute the power or index number across the bases. Okay, you can distribute these power across the bases. Law 5, a over b to the power of m. That's just equal to a to the power of m over b to the power of m. Okay, distribute the power or the index number across the bases. At the 0 power, a to the power of 0 is equal to 1. Any number except 0 to the power of 0 is equal to 1. Okay. Okay, simplify the following using index law 3, 4, and 5 at 0 power. A to the power a, so this one, bracket a squared to the power of 3. So remember this, a to the power of m to the power of n, that's a to the power of m times n. So that's just equal to a to the power of a 2 times 3, a to the power of 6. Okay, next one. Remember that a to the power of a times b to the power of m, that's a to the power of m times b to the power of m. Okay, so apply that. Its power goes to here. 3, I'm going to distribute this power to here. 3 cubed, y 3 cubed. Okay, so that's just going to be 3 cubed 27, y cubed. Remember our first here. We've done here from last previous question. So that's just y 3 times 3. Okay, 3 times 3. So 27 y to the power of 9. All right, next one. again, to the power of 2. So it's going to be distributing to each one. A over b to the power of m. This is equal to a to the power of m over b to the power of m. So this 2 is going to distribute to both the numerator and denominator. So 2x cubed to the power of 2 over 7yz squared to the power of 2. Okay, so that's expanded. 2 distribute again, 2 to the power of 2, and x to the power of 3 to the power of 2. And do it again, 7 to 7, 2 to 7, 7 squared, y squared, squared to y, 2 to y, and 2 to z squared, that's z to the power of 2 to the power of 2. So your final answer is going to be 4x to the power of 6 over 49 y squared z to the power of 4. Okay. All right, so that's a combination of index laws. Be careful with that. Okay, last 3 examples. Here we've got multiple parts. So take a look at the brackets first. Okay, we've got brackets. So bracket first. This is equal to 4, stay the same, and x to the power of 2. So this 3 distribute to each base here. So x to the power of 2 times to the power of 3, and 3 to the y to the power of 3 times 2xy squared divided by 2x squared y. Okay, so that's equal to 4x to the power of 6 y cubed times 2xy to the power of 2 over 2x squared y. All right, we can simplify here. Let me use a different color. So x squared, this is this is x to the power of 6. So x squared, we can divide it by x squared to make this x to the power of 4. Okay, so that's x to the power of 4. And take a look at the y. That's y cubed, and that's 1y. So we can simplify as y squared because 3 minus 1 is 2. And here 6 minus 2 is 4. Okay, and this 2 and 4 can be simplified because 4 divided by 2 is 2. So your final answer is going to be 2x to the power of 4 y squared times 2xy squared. Okay, and on the bottom that just becomes 1. It has everything has been canceled out. Oh, actually another one more steps. So we're going to combine them. 2 times 2, 4. Add x to the power of 4 times x, which is 4 plus 1, 5. And y squared times y squared, which is 2 plus 2, 4. Okay. All right. E, 2a to the power of 0. Any number except 0 to the power of 0 is just 1. So that's just 1. Okay. 2 times 1, which is 2. All right. For a not equal to 0. Okay, last one. Again, to the power of 0 is just 1. But make sure this 0 just is the power to the p. It's got nothing to do with the 5. Okay, so that's 5 times 1 and the plus. But here, be careful. It's 7p to the power of 0. So this entire 7p to the power of 0. So it becomes 1. Okay, it's 0 is to do with 7p. Okay, so the answer is 6. All right. That's today's recordings. Hope you enjoyed, and it's time for you to do the exercise. Thank you.